The collection and disposal of chips and dust in a workshop are a burden that comes with any old-fashioned subtractive manufacturing. And with the recent addition of a belt grinder to my workshop, I also reintroduced the airborne dust problem. I use an old industrial-grade shop vac for most of my cleaning. It's located behind a wall to get rid of most of the noise, and the vacuum is distributed to multiple locations in the workshop through plastic pipes. A couple of vacuum hoses are connected to that piping simultaneously, so the resting positions of those hoses always need to be closed so that only the hose in use gets all the suction power. However, with the dust collection attachment of that belt grinder, it is no longer possible to seal that hose when it's not in use. The solution to that problem is called a blast gate. It's a mechanical device to seal off those hoses or openings of a central vacuum that are not in use. Compared to more readily available tools, these blast gates are a bit of a niche product. You don't just buy these in your local hardware store, so if you Google them, you will find a significant portion of homemade results. And the diversity of approaches to building them is almost ridiculous. So the blast gate build is almost like the personality profile of a YouTube channel. It's like, show me your blast gate and I'll tell you who you are. So instead of telling you anything about myself, let me just build a blast gate and you will know better. These double solenoid valves are not ideal for my application. They provide more functionality than I need and they require more cabling than I want, but they're what I had. Here I added a old programmable logic controller. I have a whole box of these lying around, so I use them whenever I can. There are currently 4 cables between the controller and the blast gate. I want to bring that down to a single cable between the central controller and each of the blast gates. This is going to be a small cable management box where I go from the 4 individual cables to the single one. Small connector you see me add here is for the trigger switch. It will signal to the controller to open this blast gate and turn on the shop vac, whereas the larger connector here is the connection to the controller. The blast gate you saw me build before was some sort of a prototype or a proof of concept, and now that that worked, I updated the design slightly for the series of 3 blast gates that I'd like to build. This is the main addition of the new design, a small bracket where I can mount the solenoid as well as the cable management box too. I'm still a very terrible welder, so I normally cover everything up. I'm not a fan of zinc-plated hardware, so what I try here is to remove that using phosphoric acid, and adding some copper to that solution should help with that from what I have read. I need to adapt the size of these blast gates to fit the vacuum piping in my workshop. Unlike a traditional woodworking dust extraction system, which is high volume, low under pressure, my shop vac produces a vacuum that is an order of magnitude higher but has less volume, so you can get away with smaller diameter piping. This is going to be the enclosure for the controller. It's one of the few pieces I bought new for this project. This is large diameter glue-coated heat shrink tube. I use sleeves of that tube to connect the individual pipe elements of my vacuum piping. The pipes I use are actually drain pipes, like waste pipes. They are normally welded together with what I think is called a welding mirror. You heat up both ends and you just put them together when they're molten. This creates a very strong bond, but it leaves a large lip both on the outside and on the inside of the pipe, which is something I don't want. So the method with the heat shrink sleeves works pretty well, and it's also removable, so permanent. This is the electrical cabinet of the belt grinder. I will hook up the VFD to the blast gate so that starting the belt grinder will trigger the blast gate and turn on the shop vac. Until next time, and thanks for watching.